Good morning. This is our introduction to three-phase power for motors. What I'm going to do is I'm going to start off by talking about a supply transformer. And we're going to say that this is our transformer box. Okay, and we have a higher voltage coming into the transformer. Right now, I really don't care what it is. Okay, and we will have on the secondary of the transformer 3 phases of voltage coming out. Now then, I'm going to start our conversation off with the Y configuration. All right, so I'll start with a connection here. This is a secondary coil in the transformer. Another secondary coil in the transformer. And a third secondary coil in the transformer. And I'm going to connect these to the outgoing lines as such. And I have something over here, and I don't care what it is either. As we used to say in the service, they work fine and they last a long time. Okay, so this is our primary. And this is our secondary. And we have it in a Y configuration. Now then, if the induced voltage in the secondary, each coil, is, let's say it's 120 volts. This is the situation for my transformer. Now I can take these secondary leads and I can connect them to lighting. I can connect them to receptacles, or I can connect them to 3-phase motors or some other preferably balanced load, okay? Generally, we don't like running anything unbalanced. There are applications for that, but for this class, all of our loads and consequently our sources will be balanced. So, if you remember, in 3-phase circuits, I will have 3 voltages. They will be equal to each other. I will have 3 currents coming out. They will be equal to each other, and I will have 3 lines of power going to whatever I'm feeding, and those amounts will be equal also. The major difference is, and let me get what I need for this, is that these voltages and consequently the sources, these voltages and consequently the currents will be spaced apart from each other equally by 120 degrees. So let's pick this one as our reference, and we will say this one is at 0 degrees. We'll pick this one as the second one, and we'll say that is 120 degrees. And this third one here, we will say it is 240 degrees. Now, what I want you to remember about this is that if I take a meter, and I take my meter probes, and let's call this, let's give these a name. What do you say? Okay, so we will call this one phase A. We'll call this one phase B, and we'll call this one phase C. And I guess I should be consistent, right? So I'll make that an uppercase A. So I have 120 degrees, 120 volts at 0 degrees, and that's phase A. That's this coil right here. 120 volts at 120 degrees, that's phase B. And 120 volts at 240 degrees, that is phase C. Now, when I have this situation, and we're talking strictly about the Y configuration, we need to make some measurements here. Let's take let's call this line 1 coming out of the transformer. Let's call this line 2 coming out of the transformer. And let's call this line 3 coming out of the transformer. And let's measure the voltage of line 1 with respect to line 2. That will be equal to 208 volts. We'll take a look at the voltage of line 2 with respect to line 3. And that also will be 208 volts. Those are the line voltages. And remember, this is a balanced system. And then we'll measure sorry for the crooked line. This last one here. Voltage of line 3 with respect to line 1, it also will be 208 volts. So what we have is phase voltages of 120 volts each, and we have line voltages of 208 volts each. So the relationship that you want to remember is that for the Y configuration, the voltage of the line is equal to the square root of 3 times the voltage of the phase. Okay, we just discussed a simple three-phase transformer source. Now, what we're going to do is we're going to take this simple transformer source and we're going to use it to feed a three-phase motor. So, I've got a motor. Now, the motor has windings also, just as the transformer has windings. So, what we'll do is we will let's see if we can draw our motor first. Motor winding number 1. Motor winding number 2. Motor winding number 3. That's my motor. Now coming in from the transformer, we're going to bring a line in, put a contact in here, right? Just contactor. And we'll connect it to that phase. a second contact coming into that phase, and a third contact coming into this phase. Okay, now then, use your imagination. It's a motor. I can't just magically stick the wires into there. What I have to do is I have to go through the junction box into the rotor, and that's how we get our phases distributed. Now then, if you recall, our line voltages for this was 208 volts. So what I have three lines coming in, 208 volts, three phase, 208 volts, three phase, 208 volts, three phase. Now, when I get into the motor, it is a Y configuration. If you remember, the transformer, which we don't show now, was also a Y configuration. So the voltage drops across the stator coils. Now notice that is stator, right? The voltage drops across the stator coils will be 120 volts, 120 volts, and 120 volts. Now the line voltage for the motor, line voltage, is 208 volts. But once it gets to the phase windings, which are in Y configuration, the magic of three-phase voltage takes place, and we see this same relationship that says that the voltages of the line are equal to the square root of 3 times the voltage of the phases. Remember, this is a balanced system. It is a balanced system. That's why this works. If it were unbalanced, we would see some changes in the voltages, some changes in the currents, which may be acceptable if the balance is not too terrible. But if it is off too much, then you could incur damage to the motor or the source. So this is for a balanced system.